This is Ms. Wiles, and in this video we'll be writing an equation from a table. This video will focus on linear equations in a table. The things that we know about linear equations that help us do this are that very famous slope-intercept form of the equation of a line. And so, of course, with the slope-intercept form, we need to know two things. We need to know the slope, which is the value of m, and we need to know the y-intercept, which is the value of b. And we can remember that the y-intercept is found in the point that is 0, and then the y-intercept would be in the blank that you see there. If that point is not available to you, then you would have to use the slope-intercept form to discover or to find what b is. Now, the other thing we have to find is the slope. And if you remember, slope is the change in y, or delta y, over delta x, the change in x, which can be found with y sub 2 minus y sub 1 over x sub 2 minus x sub 1. However it is that you remember to find that slope. Now, if we have a table, our x's and our y's are arranged for us rather than giving us points that are in an ordered pair. They're arranged for us in columns. And so our x value is in one column and our y value is in the other column. And remember, the y value can always be called f of x because it is a function of x. And that's why you see f of x. It means the same thing as y. So what we want to do here is we want to find that rate of change, that slope. How much is y changing every time that x changes by 1? So the first thing we can do is check to see if x is changing, how x is changing in our table. And here, when we go from 1 to 2, it's changing by 1. From 2 to 3, it's changing by 1. And from 3 to 4, it's changing by 1. With the y values, from 7 to 14, it's changing by 7. From 14 to 21, it's changing by 7. And from 21 to 28, it's changing by 7. So we can take any one of those three ratios and get our change in y over our change in x. And 7 over 1 is our slope, which is 7. So 7 is our slope, and that is our value for m. And then we can look at our table, and if in our table we have a point where the x value is 0, then our y-intercept is given to us. For example, in this second table, our y-intercept is given to us because we have the point 0.09. However, in this graph or in this table, we don't have the y-intercept because we don't have that point where x is 0. So we have to figure that out. So in this one, we know that the slope is 7, and so we can use our formula or our form y equals mx plus b and take any x and y pair that we have in our table, substitute it into that form to discover what b is. So any one of those points will work, but since x is 1 in one of them, we might as well take that one. So we'll just take that one. In that particular point, y is 7 and x is 1. And then we have the plus b that we're looking for. We solve. 7 equals 7 plus b. Then subtracting 7 from both sides, we know that b has to equal 7. And don't be worried if b and m are the same thing. Just trust the math and go where it leads you. And so the equation for this line is y equals m, which is 7, x, plus b, which is 7. And we have our answer for what the y-intercept, the slope-intercept form of this line that's demonstrated or shown with this table is. So let's pause the video here and you try the second one, and then we'll come back into the video and go on from there. Let's go back into, before you go on, hopefully, when we subtract 7 from both sides, we get 0 equals b. So our equation is y equals 7x plus 0, and then we would just change that to y equals 7x. Thank you, Jayla, for making sure that we got that right. The second table, I'll label it 2. We're looking at the change in y over the change in x, and x is changing by 1 every time, and that's nice when they do that. And you may think, well, I don't really have to check every one of them, and you really don't. Give it a glance just to make sure that they're all changing constantly, because you'll use this procedure to determine at some point whether a relationship is a linear relationship or even quadratic, because you won't always find the same rate of change. So we look at how y is changing. Y is changing from 9 to 10. So our y is changing by plus 1. From 10 to 11, it's changing by plus 1. So that's our slope. Our slope is 1 over 1, which is 1. And so because this particular table has a point that is 0, 9, we can say, okay, that's the y-intercept. And the y-intercept, the b value, is 9. So I can take the slope that I found, and y equals 1x, and b, because we are given the y-intercept here, is 9. And you can clean that up a little bit by saying that this equation is y equals x plus 9. Now you may think, well, can I just look at it and tell? And sometimes you can, but be careful and make sure that the 0, the y-intercept, is included there. If the y-intercept is included there, then you can look at how this is changing, how the y is changing, and that's going to be your slope. So let's give ourselves some room to go on to the next problem. The next table, the first thing I like to do is look to see if I have the y-intercept. So I look at table number 3, and I do not have the y-intercept because I do not have that 0 value. Now if I follow the pattern, if I see that there's a pattern, I can make this easier just by looking at the pattern. Because I know if I have the 0 that I've got my y-intercept. And I know when I look at this, y'all help me out, how is y changing? How much is it changing every time? By 1, by a positive 1, it's adding 1. So that tells me that's what the slope is. As long as I'm looking at x and it's changing by 1 also. As long as x is changing by 1, then I can look exactly at this, at what's changing here. Otherwise, I would have to divide that change in y by the change in x. So that's my slope, and then if you look at the pattern here, if y is 0 when x is 1, and then it goes 1, 2, 3, work your way backwards and tell me what would go in this blank. If we work our way backwards, what would be the point that would come before the 0? That negative 1 would come there. So if we can work it out, whatever we can do, we can just work smart. Work with what you know, work with what you see, work with patterns and relationships. And so that tells us that this value, this negative 1, is b. Then we have everything that we need, and we can just substitute it into the y equals mx plus b, and y equals 1x minus 1. And we can clean that up a little bit if we want to and take that 1 out because we don't need that coefficient, and y equals x minus 1. If you can't figure this point out by looking at the list and you're like, I don't know what that would be, I just want to go through the procedure that I know will work. Once you find that the slope is 1, you can substitute into the formula y equals mx plus b and find what b is by taking any one of these points. In this case, we're going to take 3, 2, just because we can take any point. Y is 2 and x is 3. You don't need those both of those parentheses, but that's okay. Then we get 2 equals 3 plus b, subtract 3 from both sides, and b equals negative 1. Either way you look at it, whatever it is that you're able to figure out, any of those methods are fine. You find the value for b, you find the value for slope, and there is your equation. All right, so looking at table number 4, we see that our x is changing by 1 every time. Our y is changing by 9. We have the value for our y-intercept because we have a point that has an x value of 0. So our y-intercept is 0. Our slope is 9. And we can write that equation by y equals 9x and then plus 0. But we clean that up a little bit and we just have y equals 9x. Looking at number 5, we again see that we're changing by 1 here. They're making it pretty easy for us because x is always changing by 1. Then we look at how y is changing and it's adding 5. Now how can we find that? Just by doing 22 minus 17. Take the second value and subtract the first because you're looking at the change. And remember, if these values are going down, then your value for the y-intercept or the slope is going to be negative because those values are going down every time. But here they're going up by 5, and that tells us that our slope is 5. And then we look at it and say, okay, can we tell the y-intercept by looking at this table? And we can because x is 0 here, and that makes the y-intercept 17. If you're ever unsure about whether you have the right answer or not, you don't have to ask anybody. Take one of the other points, maybe the 332. Take the 332 and substitute the x value, which in that case is 3. And 5 times 3 plus 17 equals 32. And you're like, yeah, I got it right. And that's how you can check, by picking any point, plugging it into what you think the answer is, and checking to see if that is correct. Looking at table number 6, x is changing by 1 every time, so that's good. That makes finding our slope pretty easy to do when x is changing by 1. We look at how y changed from 3 to 10. And y changed from 3 to 10, it increased by 7. From 10 to 17, it increased by 7. From 17 to 24, it increased by 7. And that means that my slope is 7. So far, I know that I've got y equals 7x plus b. I do not have the y-intercept here because I do not have the 0 value for x. I don't have that ordered pair. So I need to take one of these points, and I'll take the 1, 3 because that's the easiest one to do maybe. Or you could take the 4, 24. For this example, I'll just take the 3, 17 just because. So I'm going to make the y 17 and the x 3. Then I have the b. 17 equals 21 plus b. Subtract 21 from both sides of the equation. And b equals negative 4. Making my answer here, y equals 7x minus 4. And you can take any one of those values, like maybe take the x value of 1. And 7 times 1 minus 4 does actually equal 3, which is what we have here. And you can say, yes, I have the right answer. So that's how you can check to make sure that you've got the right answer. That is how you find an equation from a table. And that's all I have to say about that.